On this worksheet, we're going to practice matching the names of carboxylic acids and esters to their correct structures. And I'm going to start with the carboxylic acids. Carboxylic acids molecules names all end in the word acid. So what I'm doing right now is highlighting all of the molecules that are carboxylic acids. They all have acid at the end of their name. And then what I'm also going to do is go down here to the structures and locate all of the molecules that are carboxylic acids. Here is one, a carboxylic acid is one that has a carbon-oxygen double bond with an OH right next to it. So here's another carboxylic acid and there's another. Be careful, this is not a carboxylic acid. It has an H, but it doesn't have an OH. And it looks like here is one more. So our goal here is just to match the names up with the structures. We don't have to come up with the names. And the first thing that is like sticking out to me is that I only have one carboxylic acid that has a chlorine attached to it. So that means I should only be able to see one of these options for names where I have a chlorine in the molecule's name. It's right there. So this name right here, I'm just going to use the letter C. This is 2-chloro-3-methyl-pentanoic acid. So I've got that one figured out. And then also along the same lines, there is only one carboxylic acid that has a bromine. So I'm going to do the same thing. I'm going to look at all of these names and find the one with the bromo in the name. Here it is, 2-bromo-propanoic acid. That's A. I'll put an A next to that. The other three that I have left, they don't have any really distinguishing features like chlorines and bromines. This one has branches on it. It's got 3 methyl branches on it, whereas these other two are just straight chains. So there's only going to be one name. I should have a name where it says trimethyl. Let's look for that. Right here, trimethyl hexanoic acid. That is J. So we'll put that down here. And so we're down to just these last two, and these last two we actually have to figure the name out. This is a 2-carbon chain, so its name should be based off of ethane. We should have something eth. And this is a 4-carbon chain, so its name should be based off of butane. So we should have something with like a butte in it. Here is our ethane derivative. This is ethanoic acid. So that is our 2-carbon chain right there. And here is our bute, 4-carbon chain, butanoic acid. There's that guy. The rest of these molecules are esters. All the rest of them are esters. So when I'm looking at all the rest of these molecules, I'm going to do the same thing, look for some distinguishing features. I have an ester that has a bromine in it. So let's go look for a name that has a bromine in it. Here we go. Propyl 4-bromo-3-methyl pentanoate. That's I. That will be this guy right here. What other distinguishing features can we find? Of these ones that we have left, we only have one that has a cyclohexane right there. So we should only have one name up there that has cyclohexane or cyclohexyl or something like that. So let's go find that name. It looks like, here it is, cyclohexyl. So that's D. That's going to be this guy. We've got these two that are both straight chain, no branching, so we're not going to be able to quickly find their names. This one does have a branch. We've got a methyl branch on it, so it looks like from what we have left, only one of them has a methyl branch. So let's see if we can find that name. Ester names are pretty tricky. No methyls there, no methyls there. Here's a methyl. 2-methyl propanoate. So that's going to be this guy right there. That's H. So now we're just down to these last two, ethyl butanoate and heptyl methanoate. What kind of hints can we get from these names? Heptyl is the one that kind of sticks out to me the most. Heptyl refers to 7 carbons. So in the heptyl molecule, there should be a 7-carbon chain somewhere, and it looks like 4, 5, 6, 7. This looks like a 7-carbon chain. 1, 2, 3, 4, 5, 6, 7. This one down here, 1, 2, 3, 4, 5, 6, doesn't even have 7 carbons at all. So this must be our heptyl. This is G. And then ethyl butanoate, that one is F.